last week. I'll let you guys work on the rest after we do number 8 as a class here with the time that we've got. With an average, those two values represent what? Is that the population parameters or the sample statistics?
Yes.
Is that the data for the population or for the sample? Population. Overall, all human pregnancies have an average length of 266 days or differ from that by about 16 days. What proportion of pregnancies should last between 270 and 280 days? So this is first some good review on our normal distribution and using a bell curve, using z-scores to find probabilities and cutoff scores. Let's first get 2 z-scores put together for these two values. How much more than average is a pregnancy lasting 270 and 280? So 270 minus the average of 266. What's the standard deviation? 16 days, thank you. Do the same thing for 280. How many standard deviations above average are these two pregnancy lengths? Just getting onto my calculator. 270 minus 266 divided by 16 is a z-score of 0.25. 280 minus 266 divided by 16 is a z-score of 0.88 approximately. I want to find the proportion of pregnancies that have between these lengths, between 270 and 280. So find the proportion that corresponds to these z-scores and then do what kind? Subtract. Find the difference between the two. What's the probability of a z-score between 0.25 and 0.88? Let's start with the proportion to the left of a z-score of 0.88. That's 0.8106. Minus the one for 0.25. To the left of a z-score of 0.88 is 81% of the distribution. To the left of a z-score of 0.25 is 59.87% of the distribution. So between the two, be the difference. I get 0.2119. 21.19% of pregnancies last between either 270 and 280 days. These first two parts are just review on normal distributions. We're not going to get into the sampling until we do the last few. Letter B asks us something different. At least how many days should the longest 25% of all pregnancies last? This is just in reverse. I'm asking you to find the cutoff length for the top 25%. Find 75%, I need the part to the left. The top 25th% corresponds to the 75th percentile. Look up a z-score, kind of hunt and peck on our z-chart for the 75th percentile. How many standard deviations above average is the 75th percentile?
0.68.
6.8? Is that as close as we can get? 6.7, you said?
Oh. Yeah.
Yeah. 14 10,000ths away here versus 17 10,000ths away here. So z equals 0.67 places 75% of the distribution to the left of this cutoff score. What is the z-score again?
Deviations of weight.
All right, so for this question, we are 0.67 standard deviations above average, right? All right, so we're going to add on 0.67 standard deviations of 16 days. That's how much above average we are from our average of, what was it, 266?
Yeah.
Take your average and add on the correct amount of standard deviations to find that cutoff length for the 75th percentile of all pregnancies. I got a, no, that's not right, 0.67. Got the wrong number. About 276.72 days. The top 25% of all pregnancy lives last about 276 days. Questions you have so far, reviewing a normal distribution in a z-table. Now we're going to go to sampling distributions and normal distributions. On part C, suppose an obstetrician is providing prenatal care to 60 pregnant women. Let Y bar give the average length of their pregnancies. Y bar is the sample mean. Of the 60 pregnant women sampled, Y bar gives the average of that pregnancy length for the sample. According to the central limit theorem, what's the distribution of the sample mean Y bar? Specify the model, mean, and standard deviation. These sample means should follow what distribution? What specific type of distribution the sample means and sample proportions follow? Starts with an N. N. What was it? Normal. According to central limit theorem, our sampling distribution becomes normal as the sample size increases. The more samples I take and calculate the average or proportion of, more normal that distribution should become. Let's first make sure that's a reasonable assumption. Can we assume this obstetrician selected her 60 pregnant women randomly?
Yeah.
Is 60 pregnant women less than 10% of all the pregnant women lengths out there? $60 pregnant women with their pregnancy lengths would be less than 10% of all women who've been pregnant. And then the last one, either the population is normal or our sample size is sufficient enough so that our distribution becomes normal by central limit theorem. What's our sample size? What's our sample size?
60.
Is 60 big enough?
You'd say so.
Because it's bigger than 30. I need a large enough sample for a central limit theorem to apply. And the common convention is that 30 is big enough for us to apply a normal distribution. So we'll follow a normal model. Oh, calculator. I was like, did you need something? Can I get it back? When?
I'm just using it for a test. Okay.
What should the average of my sample lengths be? I take a sample of 60 women and take their average pregnancy length. What would I expect that average to be?
266.
Why? Right. If I'm sampling from a normal population, I'd expect my sample mean to be the same as the population mean. So the average of X bar is 266 days. But sampling is a random event. Sometimes you're going to get more than you would have thought. Sometimes you're going to get less than you would have thought. There's a variability involved. That variability is given by this standard deviation. The standard deviation in our sample means is given by sigma over root n. So that's going to be 16 over the square root of 60. Yep. Take the population standard deviation divided by square roots of sample size. .066. So on average, I'd expect my 60 women sample to have an average pregnancy length of 266 days, or different than that average by about 2.066 days. Let's use that information to answer part D, because now it wants us to find the probability that the average duration of the obstetrician's patients will be less than 260 days. What's the probability that the average duration of this patient's pregnancies will be less than 260 days? That 260 is what? Is that the population mean or the sample mean? What does that refer to? Say again, Ron.
Sample.
Say again, I said
Sample.
sample. They're supposed to last 266 days, but I want to find the chance that the 60 women sample lasted less than 260 days. So how much more or less than what I would have done? Take 260 minus 266. How much above or below average divided by in terms of the standard deviation? The same 2.066 or 16 over root 6. Would my z-score be positive or negative? Why negative then, Isaac?
260, 266.
We're 6 days less than what it should have been, right? 260 minus 266 means we're 6 days under the average value of pregnancy lengths. Let's convert that difference to the standard deviation by dividing by 16 over square root of 60. My z-score is about negative 2.90. We are 2.9 standard deviations below average if our sample mean is 260 days. I want which part of the distribution, the left or the right tail? Less than, looking at the question, it says less than 260 days. So find the probability of a z-score being less than or equal to negative 2.90. Negative 2.9 gets me to what part? 0019. Approximately a 0.2% chance that the 60 women average pregnancy length is less than 260 days. Questions you have, guys? Please, good. I think there's a dozen questions total, so why don't you guys finish up the remaining few that are left, 9, 10, 11, and 12. Tomorrow, we'll do some review on S16 and 17, probability distributions and sampling distributions, and see if we can get that quiz done here on Wednesday. We are our second quiz of the semester. Next one's about rainfall totals.